Okay, now there's many different triangles that you guys can get when using the law of sines and law of cosines. Right? Right? Okay, give me one of them. One of the angles. Or one of the types of triangles. Like here, like this one, side, angle, side. Right? You can get SSA. What? Give me another one. They can give you 3 sides. Give me another one. AAS. They give you 2 angles in a side. Yeah. And there's another one. There's another one. ASA. I think there's one more after that. ASA.
Isn't ASA and AAS the same thing?
There's AAS, ASA, SSA, SSS, SAS. You guys see another one? Now, for this one right here, if they give you 2 sides with the angle pocketed, I say that because they give you the angle and they give you a side. The angle is between the 2 sides. Which law would you use? Law of sines, law of cosines? This would be law of cosines. How do you guys know that you can't use law of sines? Yeah, because it won't make a complete fraction. We won't be able to use it. Okay, this one right here gives you a side, and an angle. The angle is outside of the sides. And so now you have a different situation. Which law can you use? Law of sines. Now how come this one you can use law of sine? Because you have an opposite angle to a side. Okay? You can make a complete fraction for that one. The side. Which would you use? Law of cosines. And angle side. For this one, they give you angle and another angle and a side that is not between the 2 angles. Can you use law of sines again? Yeah? So I can use law of sines for this one. What about the last one? Angle, side, angle. Can I use angle, side, angle? Can I use law of sines for this one? No, because again, I will not be able to write a complete fraction for law of sines. Okay. Now the whole reason for me doing this is because I really want to review this one right here. This is your ambiguous case. When you get 2 sides and an angle outside of the 2 sides, it spells a bad word if you spell it a certain way. Okay? That's the ambiguous case. It's very important to know when you have an ambiguous case because you can have 0 solutions, 1 solution, or 2 solutions. Ambiguous. It's when you can spell a bad word with it. Okay? I don't know. That's how I remember it. You mean you can be like, dang, that girl's ambiguous. No, don't say any stuff like that. Like, we know what you're talking about if you say stuff like that. Okay. So, if you are given an angle, see, you're given one angle here. If you're given an angle, wait, my arrow's not even pointing to the angle. If you're given an angle that is obtuse, your job is really easy. Because if they give you an angle that's obtuse, let's say they give you angle B, and that's an obtuse angle. It says 0 or 105. Okay, that's an obtuse angle. And then you don't even care about your sides too much. You have B, your opposite side, and give me another C. Okay, that sounds good. Okay, so B is your opposite side. Let's say that side is, I don't know, 25, and this one is 15. You don't even care. You just set up your law of sines, and 2 things can happen. One thing can happen, like you get an answer. If you get an answer, then you know there's one solution. What if your calculator says error or syntax error?
No solution.
That means that there's no solution. So you don't even really have to think if you have an obtuse angle in the ambiguous case. Okay? All right, you guys understand that? No thinking? Oh, love the no thinking, Mr. Patey. Okay. What about if it was an acute angle? Now this has a different situation. Okay, if you have an acute angle and then you set up law of sines, you plug it into your calculator and it says error. What do you got?
No solution.
No solution. Oh, that's cool. Still, that doesn't require any thinking, huh? Oh, that's nice. Okay, but if it does give you a solution, that's when the poop hits the fan. That's when you have to figure out if there is 1 solution or 2 solutions. So there's only one situation, only one scenario where you have to figure it out if it's 1 solution or 2 solutions. Because all the other times it renders itself the answer. The answer is rendered. Okay, so let's pretend that this one gives us a solution. Actually, let's make sure. Can you guys plug this in your calculator to make sure? Okay, let's check really fast to see if this one gives us a solution first of all. So it's going to be 15 times sine of 75 degrees equals 25 times sine of c. So you're going to divide this by 25, and then you're going to take the arc sine or the sine inverse of this. So can you guys do that? Tell me if you guys get an error. You guys got an answer? 35.4? 2. Okay, so we got an answer. That is angle C. Okay, but the question is it just this one solution, or are there two solutions? Okay, and this is how you guys know. Okay, ready? Ready? This is how you know. I'm going to draw a visual here. So we're pretending that this is 75 degrees. What's the opposite side measure?
25.
The opposite side measures 25. What is the... Yeah. Opposite side measures 20. What's the other side? 15. So I like putting the other side right there. This kind of helps me give me a visual. Now this other side that I'm going to draw right here is going to be 25 units long. Okay? Now, is that going to... I mean, how many triangles can I create with that? With that 25 side? Can I create 2 triangles or just 1 triangle?
2.
Well, I can create one right here, right? It would definitely be longer. Because, I mean, 25 is bigger than 15. It'd have to be longer. Can I create one of these triangles? Like if it was 15 and this is 75. Can I like draw a line right here? Can I make that 25? No, that would not work. Why would that not work? Yeah, because this line right here, like pictorially, this illustration has that line as being a smaller line than 15. And that's not true. It's not. So this one has how many solutions? This one has 1 solution. Okay, so you would just take this answer and keep going and find all your other answers so you solve the triangle. Does that make sense? Okay, but what if, like, what would you have? What would you have to have so that would be 2 solutions?
The other way. Shorter.
Here, let's switch some things. Let's make instead of B being 25, let's make that one 10. Okay, so we're making it 10 just to switch it up. Let's see if we get 2 solutions here. Now, if I plug in 10 for B, that means this is not 25 right here. This is 10, and that's not 25. That's 10. Can you guys see if I still get an answer for this one? So this one doesn't work. You get an error. So let's not do 10. Let's do a slightly bigger number. Let's do 13. Let's see if 13 works. Can you guys plug that in to see if it works? Strike out again. Okay, instead of 13, let's try 14. 14 doesn't work?
Do 16.
I'm gonna try.
Okay, then let's just try 2 different numbers.
Wait. I'm gonna try.
Okay, so we're gonna put in. Let's just try 30 right here, and let's try 28 right here. So that's going to change a couple things. I'll make those changes right now. So because I chose the bigger angle, this has been more difficult than I thought. Okay, so instead of 28, I put 29. You guys said it worked, right?
Yes.
Okay, so I put 29. What does it give you approximately for C?
It gives you 87.76.
87.76? Okay, so we're just going to put 76 right there. Okay, so if you got an answer and you have an acute angle, then what you're going to have to do is you have to look at these and try to figure out if you can have 2 solutions. Now, if I draw this, I have a 75-degree angle right here, and this side right here, the other side is 30. Now, if this side is 29, can I draw a triangle that looks like that? And would I be able to draw a triangle that looks like this? Would that make sense? So in this case, you know that there's 2 solutions. If you have 2 solutions, you have to take this angle right here and find your other C. Your other C would approximately be 180 degrees minus whatever you got, 87.76. Now, if you have that number in your calculator, not the rounded one, but if you have the whole number in your calculator, just just subtract 180 or add 180, whatever you got to do to find the difference between the two, and then you find your other c. And once you find your other c, then you can find the rest of the parts of the triangle, and you find your two solutions.